I'm Jon Leach, and day-to-day I lead a team of structural engineers in London for AECOM, but I also chair the institution's panel for digital workflows and computational design. So I'm going to speak now just for 25 minutes or so about what the outlook of that panel is and what we're trying to achieve on behalf of the institution, really. Talk about why we feel there's a need for this now and where this is leading, what the key messages are for our members but also for our clients, and how we get started with this. I think there was a lot of really progressive looking talks this morning. There's going to be more to come this afternoon. I'm going to try and bring some of this back down to earth and say, how do we actually get improved uptake of this technology, not just on the higher end projects? So first, a quick introduction to the panel itself. So it was established in 2017, and it's a panel across multiple disciplines and many different consultancies and partners. So there are structural engineers, obviously, there are also architects, fabricators, and we're getting increasingly strong links with academia as well, supporting research projects, contractors, and also software developers. So the idea is that we've created this hub to discuss all of these different points, which I'll come to. In terms of its position within the institution, not sure how many people are aware, or indeed how many people can even read that from the back, apologies. But the engineering leadership group, which reports directly to the board of the institution, has a number of committees. The digital workflows panel reports into the structural futures committee, which Ed Clark chairs. So it's a self-contained panel, but it also collaborates a lot with other panels, particularly the research panel and obviously the BIM panel as well. We meet 4 times a year. It's so far been a very strong panel, also involved very much in the organisation of today. And there's a number of work streams and projects that we're covering. I'll come back to these in a moment. In summary, looking at technical guidance, interoperability as a focus, research and training. I'll come back to that towards the end. First of all, as it's after lunch, I'm going to really bring things back down to a very simple level. The reason why I'm asking such a sort of slightly dumb question, I guess, is the word digital is very much kind of the buzzword of the minute, and it tends to be misused quite a lot. And I think a lot of people and businesses, and I include my business in that, have kind of created this thing called digital, almost like it's a product in itself. The reality is we deliver professional services, and we design, we build, we manage, maintain and operate buildings and infrastructure. That's what we need to focus on, and we need to look at things differently. We're not selling digital as a product. This is what we do day to day. So what is digital in this context? Basically, we're creating toolkits to enhance the delivery of those projects. In terms of how we're doing that, from our perspective, we see this as a combination of evolution and revolution. What I mean by that is a lot of the stuff we're doing right now is just enhancing traditional methods of design. We're just making things a little bit simpler and a little bit more efficient. Ultimately, through doing that, we're creating new methods and potentially creating new services to bring to clients. So really it's a mindset and a culture which is partly to augment and partly to automate our delivery processes. So a little more on that. We're creating this toolkit. It needs to be modular, it needs to be scalable, it needs to be applicable to all ranges of projects, not just the higher end of projects that you often see in the case studies. So in terms of how we might think about structuring this, we have our core platforms. Everybody here is going to be using these core platforms. We all use some degree of analysis software, some degree of documentation software, sometimes CDEs, digital design reviews as well. But then having got that right, and that's really what we're trying to get everybody to that point where we're doing that bit well, then you can start overlaying the more complex toolkits, the more sort of basic interoperability plugins, the use of data hubs, which was discussed in the panel this morning, and ways of sort of automatically auditing this information as we're developing more and more data out of this. And we'll then start layering other technologies, and they'll just all plug into this. So immersive technologies, digital surveying and capturing. Again, once you've got these basic core things right, all of these become an awful lot easier. And then looking more to the future, and well, the current for some of these, once we've got that data, using machine learning, using multi-objective optimization, more sort of complete robotic manufacturing methods, So the message, and I think this was made fairly clear in this morning's panel discussion, is having that data integrity from the beginning of what we're developing allows you to take these transformative steps. So from the institution's point of view, and I guess all of our points of view, why now and where is this leading? I think we all understand the pressures we have day to day, time, cost, quality, the famous triangle. Basically, all of those are being squeezed on us. People want things done quicker, they want it cheaper, they still want to maintain the quality or indeed improve it. And we feel the gap is widening between the construction sector and other technology sectors in general. Now, our industry is very complex, and what we produce is very complex. It comes back to what was discussed this morning about the concept of mass customization rather than mass production. It is a different mindset that we have, but the industry is still very fragmented. And the innovation and excellence that we see is still really only in very limited pockets, and we need to expand that. And we believe structural engineers are in a very good position to start re-engineering that whole design and build process. So, in terms of, thinking of the master builders of the past, your Brunels and others, who basically had this single point of responsibility. Yeah, life was simpler then, right? But these people were designing it, they were funding it, they were building it. They had that whole life responsibility for what they were creating. Since then, buildings and infrastructure, they've got more and more complex. You have more and more consultants, more and more niche specialisms. What we're saying now is, through these technologies and these workflows of starting to stitch this data together, you start to bring that collaboration back. And although things are still too complex to have kind of one person driving everything, you're trying to create this kind of master builder team, which is a much leaner team, where they're sharing all of that data in a more automated environment. These slides get more and more wordy, apologise for this. But this kind of summarises, I guess, we all work with some sort of plan of work, the REBA plan of work typically. And the current plan of work is actually being updated to reflect some of what I'm going to raise here. A lot of the problems we have here is the gateways naturally cause us to stop and start the whole way through the process. We're kind of creating models which are then just binned off and recreated by somebody else right the way through the process. It's very wasteful. You're losing all the data integrity. How often are we asked to do, an LOD 300 model in the knowledge that nobody's going to actually use that in the future? A fabricator is going to just rebuild their own. That's what we need to get away from. We do have early contractor involvement, but again, the way supply chains operate, it's very complex. We end up with consultants on one side, contractors on the other, and still very limited overlap in how we actually interact. So a plan of work for the future, we're not going to get rid of the design process. It's still that iterative, gateway-driven process. But we start to look at how we can bring models and data right the way through the process more seamlessly. So it's more of a sort of turnkey delivery approach. So we have more semi-automated design up front, which gives us much more clarity, much more informed decision-making, and takes us much more quickly to stage 4, the technical design side of it. We also then be able to take that information from stage 4 and start moving straight into fabrication. And this really is a shift of mindset that I think we all need to get our heads around. Yes, we have our agreed scopes. We need to start thinking slightly differently. We need to start looking, as consultants, we need to be much more engaged with the end product. Likewise, as contractors, we need to be looking much more at the design process and how it all informs itself. So the messages that we're trying to identify, the internal messages, and these are the messages to members, to structural engineers. We're looking to automate the mundane processes, but we're using the tools to augment the creative process. So in other words, we've got to bring value. We need to keep our core professional skills. We're not talking about like the machines taking over and designing everything, because that loses all the passion in everything we're doing. We need to add value to exist. The Farmer report recently, modernise or die. It's that kind of, that's where we are now, and we have to change these things. And we're saying we do want to avoid this loss of control. We need to drive this. At the end of the day, good ideas, innovation does not come from the computers, it comes from people. So we need to drive these and see the digital processes just as tools to get there. And also, I think it was mentioned in one of this morning's talk, the importance of communication. Again, there's so much reliance on shifting around massive bits of data electronically. We need to talk. We need to sit in rooms or talk to avatars. However we do it, we need to talk. And that's the underlying thing of all of these design processes. And the point we want to make sort of on behalf of the institution really is structural engineers should be on the front foot for this. I think too often we kind of follow other people's processes. We can be in a position of leadership, partly because what we do already suits a lot of the workflows I've been talking about. We're already much more in control of the end product compared with some other disciplines. We don't tend to select our things from a catalogue. What we design is what ultimately gets built. We're also first up in the delivery phase, so programs normally are driven by getting piles in the ground and building the frame, so we can be part of driving this process. And in terms of digital integration, we're actually traditionally have been ahead of the curve because we already have some quite good integrated tools, and to be fair, structural analysis in terms of the data we're carrying around is actually quite straightforward compared with what some other disciplines have to deal with. So taking those messages externally to our clients, we're improving efficiency, we're reducing the delivery program for our work, but also we're looking to improve the downstream delivery program. We're looking to enhance our product so it's more usable further down the line by other people. We're bringing value, and this is another really important, using the word value and not cost. We're not necessarily trying to reduce our fees. Ideally, we're trying to get more scope and more fees, but it's a mistake that's often made. You focus on value, you focus on bringing more quality to the deliverable and reduced risk. And optimization. And by doing this, you know, there's computational optimization, but there's also just using models to visualize things more quickly and inform decision making of perhaps the lay client who needs that visualization process to understand what's happening, and also, you know, the obvious coordination that these methods bring as well. So in terms of breaking down this workflow analysis, first part is understanding what are we delivering and what do clients want and why do they want it and what should we be offering them. And we shouldn't be afraid to challenge this and innovate it. A lot of the time we'll just get an RFP and we go, okay, that's what you want, and we respond to the RFP. We really need to start challenging these things. The classic example is 2D drawings. So trying to portray the benefits of 3D models to people. A lot of people still think it's better to produce 2D drawings. A lot of clients still think they want them. The reality is the benefits are obvious. They're obvious to us. They're also obvious to the client. The bottom one there, the use of facilities management tools, or sometimes it actually seems a bit of a pain for us, I guess. We're putting what we see as unnecessary data in our models for the operational aspects of the building. But the benefits of doing that means that further down the line, actually you can start getting feedback on the performance of the building and feeding that back into our design optimization process. So we need to look more holistically really at what we're delivering and why. Other examples of this, and this just comes back to how we respond to scopes really. People ask for 2D drawings, why? It's usually because a project manager has got a master list of drawings that they've had for 20 years, and they say that's what you want, you know, 500, 1 to 100 drawings and whatever. Why do people use them? A QS is really using them. They're usually calling things off the model in reality. So question the EIRs, question why we've been asked to produce things at particular stages. You know, why are we producing really data-heavy models at inappropriately early stages of the design, for example? Also question why might a client mandate a particular piece of software where we believe another one can do it better. With all the interoperability we've been talking about, you don't need to wed yourself to a particular piece of software. So a case study of this is a project that we've been working on for a number of years, Hong Kong International Airport. So from our London team, we're currently delivering the roof and facade of both of these buildings, which is the Terminal 2 redevelopment and also the third runway concourse in development. Two massive buildings. So yes, we're using parametric tools and all manner of complex workflows to deal with the geometry and the amount of data. But the more interesting story here in relevance to what I'm talking about now is actually what our deliverables are. So when we were originally appointed on the project, our deliverables were 2D drawings. Here's a list of 2D drawings. This is what we want in 3 years' time. So we embarked on doing that, but quickly started to demonstrate, I guess, the folly in doing that. So 2D drawings like that are great, but when everything's curving all over the place, they don't really tell you an awful lot about the complexity. We're responsible for the connection design as well. We've had to draw all the connections, but we've done that in the absence of doing an erection phase analysis, so it ignores all the locked-in stresses. So in reality, that will be thrown in the bin in 6 months' time, and the contractor will be redesigning it. So really, what is the point in doing that? So we're lucky on this that we do actually have quite a progressive client, and we've had these discussions with them. So what we're now providing is we are looking at the erection phase analysis based on some of the more credible methods of building it. We're including the locked-in stresses, we're completing the design, and we're completing pretty much an LOD 400 model, which is a shot model with everything except for presets and precambers and shot marks, essentially. And we're only producing 2D drawings once. Unfortunately, yes, we still have to produce 2D drawings because in Hong Kong, they have a pile of drawings that they rubber stamp physically, and that's what they do. But we're not doing that at interim milestones and wasting all that time. So in doing this method, firstly, we've increased our scope and we've increased our fee, which is a good tick for us. We've de-risked the tender, which was the fundamental reason why the client wanted to do this. But we've also, by eliminating the 2D deliverable, we've managed to do all that within the confines of the program we originally had. So this is what I mean by, having the confidence to challenge what we're delivering and how we're delivering it. So having defined what we're delivering, we then start looking at mapping workflows. Again, this has sort of been discussed in the morning. I'm not going to dwell on this too much, but it's pretty obvious, I guess, at the end of the day. We have inputs, we have processes, we have dependencies, and we have outputs. And we have a timeline that we put that against. But it's very rarely that, as engineers, we actually think about engineering the design process like this and applying that kind of like systems engineering approach. This is the way we need to start thinking, because this is how we link all of that data together and map it all. So this is a typical workflow for something very straightforward. I've put this here just to say we can keep things very simple. I think the mistake people make is they do try to boil the ocean and they try to map every single aspect of every single interdisciplinary thing. We are professionals at the end of the day. The human element remains, and we need to rely on our skills. We don't need to write everything down that we've ever learned, ever. But we do need to apply some logic and process. And from this, you can start mapping out what your optimized workflow is. And then you start looking at what data you're trying to manage during that workflow. So again, you're listing your typical input parameters for structural design, and then you're mapping what your output parameters are, what are the important things that we're trying to deliver, and then looking at how we can parametrically link that with data. So typically, that's what we link. We might establish a geometry and an analysis model and port it over to Revit, or vice versa. What we really need to be looking at is how we do that across the board on all this information. So again, you're using this hub of data, which is then feeding out to all the different bits of software. You never lose that data integrity at any point, and it's also embedded in your ultimate deliverable. And to do that, we're using more data intelligent file formats. So the ones on the left as opposed to the ones on the right. That doesn't mean we don't use the ones on the right at all, but it means in our digital workflows, we're focusing on these data-rich formats. And that avoids this scenario. So again, apologies, you probably can't read this at the back, but what this is really showing is very typical workflows that we still find engineers and technicians using. So we'll have a parallel workflow where somebody's setting up a model as a technician, as a documentation model, because we need to share it with the architect very quickly and we need to get everything into a federated model. Simultaneously to that, engineers are building their own models, and you end up with just two data dead ends, and the two never quite blend together. Sometimes this isn't too terrible a workflow. If it's something really simple and you think you're going to do it once, then this is still an option. But I can't remember the last time that ever happened on a project for me. So this is the kind of model that we need to move towards, which is more about having this centralized data hub. So again, there was discussion on this morning, but something that we've done is to basically store all of those parameters on the left and the right, if you recall the previous slide, in a Grasshopper database. and that then feeds out to the analysis software. It also feeds out into things like fire engineering software, CFD software, MEP where relevant, particularly in terms of the environmental performance, also cost consultancy, also things like constructability. So you can start to build in parameters to your data sets where actually you're limiting the size of components based on your crane capacity. So something we did on Hong Kong, for example, is effectively it's an automated routine where we're looking at the maximum size of components which are transportable. That locates the splice, and you're then optimizing that structurally within those parameters of what is transportable. So you're just layering in that data and optimizing it that way. And then it's basically ticking all of those boxes. So back to the panel, just to finish off. So hopefully that was a fairly high-level summary of where we're coming from, really, but this is what we're trying to encourage, is that kind of workflow planning and that algorithmic way of thinking, which enables these methods on more straightforward projects. So as a panel, we're firstly providing more technical guidance for members. So as part of the panels area on the website, we're starting to populate that now with guidance notes which have been created by the panel members. We're looking to develop that ultimately into more interactive applications as the new institution website comes online. There's also been a number of journal articles and publications already, and we're supporting more of those, and also trying to bring in more case studies as well, which are, again, less high-end and more, I suppose, day-to-day. We're also talking a lot about interoperability. So, again, a lot of the discussions this morning we've been having as a panel, engaging with software developers and really trying to guide and steer the developments and say, what are the needs of the industry? And that comes down to the more pragmatic concerns. How do we audit these things? How do we deal with QA/QC? Where does the liability lie when you start kind of merging data and nobody quite knows who owns it anymore? Right the way back to simpler things like data security when you're using cloud-based environments. We're also doing lots to support research. So as well as providing a forum in itself, we're supporting a number of academic studies and kind of trying to bring our industrial expertise to steer those studies. We're encouraging research by having discussions like this, hopefully, and also building on existing research. And finally, in terms of training, as well as forums like today, ultimately we're trying to manage this cultural change. So all the other things I've talked about, hopefully that starts to infiltrate into the industry and people start taking note. We are having discussions more widely with education panels and having those discussions of, you know, what do we need to change in education? Do we need to focus on programming, or is it a case where actually the next generation coming through just do programming anyway? I mean, my 8-year-old daughter does better programming than I do, frankly. So do we need to worry about that so much? People are already equipped to do that sort of thing. And it comes back to this two-way learning or upward learning, and us being more receptive as senior leaders to understand what the new people coming through can do for us, but also imparting our experience on them at the same time, and organising CPD and training. So to finish up, because I think I'm probably running over slightly, in terms of a timeline of where we're at, things are moving very quickly. I think this is all I need to say on this matter, really, and it's accelerating, ever accelerating. And for those of us who are not already here, we're going to struggle like hell to get to here. And it's happening very, very quickly. And as I think you start to see, a lot of the high-end work is already using these genetic algorithms, the optimization processes. If we're not at the bottom of that curve now, we're never going to make that leap and connect to where things are going to be. Probably within only 5-10 years tops, this is going to be commonplace. So this is where we are now. We have a limited number of leaders, and we have a lot of people who are on the fringe. And where we obviously want to get to as an industry, as an institution, is more like this. Hopefully forums like this can help, and hopefully everything else the institution can do is going to help. So just before I finish, In terms of contact details, I'm there, but also Ashley, who is employed by the institution as a senior engineer. So a lot of the content and a lot of what's been developed, Ashley's been quite instrumental in developing. So you can applaud him or blame him as you wish. And I just wanted to close on, just to show you the website. So at the moment, things are quite hidden in the website, to be fair, but you're basically going to the panels place, and you can find the digital workflows and computational design panel at the bottom, and the content is starting to be populated there. And as I say, as the new website comes online, that will become a lot more interactive and intuitive. At least that's the hope. Okay, thank you very much.